All right, so we're going to move on to note 7.2, which is called properties of parallelograms. So in the first section, we looked at different types of polygons, and today we're going to focus on quadrilaterals, but even more specifically, a parallelogram, which is just one of the many number of quadrilaterals that we have. So you can read the definition there, and I know as we go through these, you're going to think, oh, this is easy. There's 5 properties, but I need you to really be careful with really knowing the properties of parallelograms, not just reading number 1, 2, 3, 4, 5 and be like, okay. Because honestly, the definition of a parallelogram is pretty easy. It's a quadrilateral where both pairs of opposite sides are parallel. And sometimes people just kind of overlook it. So when we take a look at these 5 properties that we're going to use, I want to first talk a little bit, and you can remark on your diagram, and most of you probably know this, but this property right here, okay, I'm going to put a star by it because it is the definition. So even though we call it a property, knowing that both pairs of opposite sides are parallel, and I'm just going to remark these, but you know that this, marking, that means those two sides are parallel and these opposite sides are parallel. Those are supposed to be triangles. But just know that that is the definition, okay? As we move on to number 2, the opposite sides are congruent. So in this diagram, PQ is equal to SR and PS is equal to QR. A third thing that you probably remember about a parallelogram is that the opposite angles are congruent. So angle Q and angle S are equal, and angle P and angle R. And then for number 4, you might want to write this down. Just the fact that if you can remember, most of you should remember what supplementary means. So I don't really want to mark anything because I don't know. We know that the opposite angles already from number 3, X and X. So, but the whole idea here is that if you add angle X and angle Y, it's always going to equal 180 degrees. So these two angles equal 180, these two angles, and those are consecutive. Remember, consecutive means right in a row. And then the 5th theorem is that the diagonals bisect each other. And we should know this definition from earlier this year, but bisect means that it's going to cut it in half. So basically, you might want to write down, I'm going to write this over here, and is that we know that if the diagonals bisect each other, that QS, okay, and PS, I'm going to just write this down again. In this diagram, QS and PR, that should be an R, I'm sorry, PR bisect each other. So in this specific diagram, we know that PM is congruent to MR. And we also know that QM is congruent to MS. All right? Okay, let's go ahead and go on. So what you might want to do is try these examples on this next page on your own. Press pause on the video, and then you can check them with me. That way, you kind of see if you're really applying those 5 properties on the front. All right, so in example 1, we have parallelogram ABCD, and we have our diagonals bisecting at point E there. So let's go ahead and make sure you understand these questions. So it says, name the property that justifies the statement. So we know these statements are true. We just have to tell what property on the front. And you can just write them out. I would not write like number 1, 2. Just write them out so you have them in your notes. So why is DE equal to EB? Well, that's because the diagonals of a parallelogram bisect each other. It just helps to write them so you kind of review the properties. Why is CB in this diagram equal to AD? Because in a parallelogram, opposite sides are congruent, or their symbol for congruent. Why is angle DAB, which is right here, equal to angle BCD, which is right there. That's because in a parallelogram, opposite angles are congruent. Y is angle ADC, which is right here, this big one. When you add it to DCB, 180, and that's because in a parallelogram, consecutive angles are supplementary. Come on, pen. There we go. Okay. And then finally, why is it, and you got to be careful with this one, it's a student sometimes struggle with, I'm going to erase this so I can go back to my diagram and mark on it. But what happens is they struggle with understanding what this 2 times AE means. So here is AE. So if you have 2 of them, basically what it's saying is that it's the same as that whole thing. So I'm not worried about, I think you know, the only property that would make sense here is that the diagonals bisect each other, okay? But what you might want to remember is that this whole 2AE thing is basically saying that if you take 2 of these, AE plus AE, that equals AC. So we have one and another one, and that equals the whole diagonal. But remember, if I use substitution, AE in this diagram is the same length because the diagonals are cutting in half as EC. And so that's truly kind of in a proof kind of way, that's how we kind of understand why the property, the diagonals bisect each other, is the reason. Okay. All right, let's go on to example 2. And in example 2, you're just deciding whether you have enough information in the figure to determine if it's a parallelogram. So I'm hoping in A you put no. And the reason is that you know in this diagram that you only have one pair of opposite sides that are congruent. And we don't know about the other 2 sides. We don't know their lengths. So we can't say, oh, opposite sides are equal. And then it only has marked that this pair of opposite sides here are parallel. And once again, we can't assume the others. So that's why that one is a no. Now for part B, for this parallelogram, what's marked is that this diagonal is cut into equal pieces and this diagonal is cut into equal pieces. So this is a yes. And all you have to do for the explanation is to write down that the diagonals bisect each other. And that's just using one of the properties from our front page as a reason. Okay? All right, let's move on. And once again, I highly suggest that you maybe try these. If we were in class face-to-face, say, hey, let's do these examples together, or try them on your own first, then we'll come back and check them. All right, so you might want to pause the video again. All right, for example 3, let's check your answers. So we have parallelogram PQRS. So I'm hoping that you saw that if PQ is 17, then RS is 17. If the measure of angle R is 73, then Q would be its supplement because they're consecutive. So that means Q would be 107 degrees. And then P, because it is equal to R, would also be 73 degrees. If PT is 5, that means the other part of the diagonal is 5. Therefore, the entire diagonal PR is 10. If QS is 19, then ST needs to be half of that. So that's how I got 9.5. And then for E, PS, and QR, because their opposite sides are equal, so I'm going to set those 2 expressions equal to each other. And when you solve that little 2-step equation, you should have gotten X is 3. Okay? So pretty straightforward. I don't think these are hard examples. It's just really trying to process those properties. So example 4. What's given, these 2 angles right here are not congruent. So I just want to make sure you know that this angle right here that I'm kind of highlighting on 60 and this angle right here, they're consecutive, which means that these two angles are going to add to 180. So that's the equation, kind of sloppy, but that's our equation that we would use. So now all we have to do is combine like terms. And remember, you're always going to show your steps as I do, kind of walk through them. So you would add 52 to both sides. No, I'm sorry. Did I write that down wrong? Yes, I'm sorry. That should be a plus 52. My bad. So, sorry, I was like, what am I doing? So you're going to subtract 52 from both sides, and then when you divide by 2, you should get x equals 64. And that's all it asks for. Okay? For example 5, you're given a parallelogram. The two expressions are on opposite sides. So we know that opposite sides of a parallelogram, that's the property, are equal to each other. So here is our equation that we would set up. And once again, I would probably add 11x to both sides to give me 14x minus 5 equals 23. Then I would add 5 to get 14x equals 28, and therefore x is equal to 2. That's all it asks for. Now we can check it by plugging 2 back in. So 3 times 2 minus 5 is 1, and then checking it up here. So you can plug it back in and make sure that those values are equal, okay? And then the last example to wrap up our notes for the day is we have a parallelogram, and what's marked is you know that this is 3x plus 4, and this part of the diagonal is 4x minus 1. So the property they're wanting you to remember is that the diagonals of a parallelogram bisect each other. So we're going to take these two, and they're going to be equal parts. And once again, you're just going to solve this equation. And if I subtract 3x, I get x minus 1 equals 4, and I quickly can get x equals 5. All right? So that's it. Those are our second set of notes, and we will be practicing this concept for a couple days and then moving on next week. All right, thank you. Bye.